See, the today concept is expression evaluation. So first of all, so what is expression? What is expression evaluation? Why we are using algorithms for expression evaluation? So normally, I'm doing what is that simple expression? Expression is a collection of operators and operands. Operands simply we can call it as a data. Simply to say a plus b, or suppose here it is 2 plus 5. 2, 5 are operands where operation will perform. Where operation perform. Plus is an operator. Is an operator. So combination of operands and operators will give the expression. Okay, but evaluation. So normally, if you want to evaluate an expression, three types of expressions are there. One is infix expression. Third one is prefix expression. Second one is a prefix expression. Third one is a postfix expression. Infix expression means, for example, see, let's suppose x plus y. That operator is in between operands. Here it is prefix means what is preceded by, and postfix means what, here it is a after followed by. Okay, see, seems to be infix expression seems to be good to see, but evaluation is difficult. So why the reason is need to consider priority of operators. Like for example, if you write one expression like this, here it is a 2 is multiplied with 5 plus 3 is divided by so suppose here it is a 7 minus 4. First this one execute, next one evaluation priority, this one execute, next this one execute, next priority this one execute, like this it will go. So priority of operators we need to consider, but in case of prefix expression and postfix expression, no need to consider the priority of operators. So first of all, first one, conversion. Given expression we need to convert into, given infix expression convert into prefix and postfix. After that, just evaluation algorithms. So for conversion algorithms are there. For conversion algorithms are there. Once converted successfully, then evaluation algorithms are there. So we'll see. It's an easy way we can understand. But this is the story. So why three types of expressions? Why we need to go for prefix and postfix expression instead of infix expression? If they ask the questions, you need to answer this. So now let me explain with the examples already given clearly. The first one is, if you want to convert infix to postfix, we are using stack algorithm. So what is this? How can we implement that algorithm? All these things we are discussing here. The first one, suppose I have given here algorithm to understand more clearly. Side by side examples I am giving. This is infix expression. One by one we are taking. Is the first one, is the second one, is the first one, is the second one, and is the third one. First operand, next operator, next again operand. Okay, so we are taking stack one by one. Initially stack is empty. If it is an operand, look at this. If it is an operand, directly output it right into the postfix expression. If it is an operand, directly into that postfix expression. Got it? Next one is, if it is an operator, okay. So what this operator will do, if it is an operator and if the stack is empty, so many options are there, but in this example, all these all these options will not come, only one. If stack is empty, yes, stack is empty. Push operator onto the stack. So output X will come here. It will continue in the next step. Next one is an operand. It's an operand. Operand means directly output it. Directly output it. Next one, nothing is there. So if no more input, unstack all operators from stack and output it. Only one is there. Collect and output it. So in this algorithm, to evaluate the small one, we are using 2, 4a and 7. Okay, next one more. Suppose this is the one. So here what we are using. So observe this. Observe this. First one is a X that we know, directly output it. If it is a plus, yes, if stack is empty, directly you can push operator onto the stack. And this is same, it will continue. Next one is a Y, is an operand, directly output it. So it will continue. Next again operator comes. Look at this. This is the new one in the second example. If it is an operator, if stack is empty, no, stack is not empty because stack is already contains plus symbol. So first one wrong. Now the new operator has highest priority than top of the stack. The top of the stack is what? Plus. Top of the stack is what? Plus. Multiplication is having highest priority than plus, na? Yes. Then if the operator has highest priority than top of the stack, push operator onto the stack. Yes, we pushed operator onto the stack. Got it? XY will continue. Next one is an operand. Z, X, Y, Z. X, Y, Z. Next one is a star. And here it is, it will go and store. If no more, is a pop means what? Last in, first out. So first the star will come, next plus will come. So this is for the given infix expression. This is the postfix expression. This is only conversion. Then after conversion, what we will do, sir? By inserting some values, we will evaluate. For evaluation, one more algorithm is there that we will discuss later. Okay, here only one point covered. It is extra. Next, this is one with parenthesis. With parenthesis, same story. If it is an open parenthesis, if it is an opening parenthesis, directly you can push it onto the stack. Directly you can push it onto the stack. So postfix is empty. Operand, directly you can add to the postfix. If it is a star operator, see, if it is an operator, and look at this, now be covered. If the top of the stack is opening parenthesis, if the top of the stack is opening parenthesis, yes, top of the stack is opening parenthesis only, then you can push operator onto the stack. Next B, yes, AB. This is important point. If it is closing parenthesis, if it is closing parenthesis, pop operators from the stack until opening parenthesis is encountered. You keep on pop the operators from the stack, okay, and you keep on adding until opening parenthesis encountered and discard. No closing parenthesis, no opening parenthesis. Sir, why, sir? Because what is the meaning of opening parenthesis, closing parenthesis is a priority, na? But I already told you that either prefix expression or postfix expression. Postfix expression is not allow priorities. Not allow priorities. So these should not contain parenthesis. Should not contain parenthesis. That's why we should discard, pop and discard the opening parenthesis. So whenever closing parenthesis comes, until opening parenthesis encountered, you keep on collect the operators and add to the postfix expression. Now, plus came. Yes, the stack is empty, na? You can directly push. Next C. Whenever it is a C, directly you can add. Now no more input. Then unstack all operators and output it. So if this is infix expression and this is the corresponding postfix expression. This is the corresponding postfix expression. Is the one. Now observe this. Now observe. Here it is. Here it is. First opening parenthesis came. Yes, directly onto the stack. Onto the stack. A directly output it. Next one is a plus. Yes, if the top of the stack is opening parenthesis, push it. Next B, directly output it. If it is closing parenthesis, until opening parenthesis encountered, collect all and add to that postfix. Next is an operator. Stack is empty, directly push. If it is an opening parenthesis, directly you can push it onto the stack. Next X, operand. Whenever it is an operand, directly output it. Next, if it is an operator, if the top of the stack is opening parenthesis, you can push operator onto the stack. Next Y. Next closing parenthesis. When it is closing parenthesis, until opening parenthesis encountered, you need to add. Not all, only up to opening parenthesis encountered. Next, no more input here. So finally, only one operator is there. Just unstack that operator and add to the postfix expression. Add to the postfix expression. This one. Now. Right. Next one. Next one. See, this is also important. Try to understand. Right. Now look at this. The first one is an operand. Yes, you can output it. Next one is a star operator. If stack is empty, yes, you can push. Next it is Y. Yes, directly you can output it. See, next one is a plus. This point is important. Last time, nothing but in the second example, if the top of the stack is suppose plus, and if you want to insert star or divided by, compared to plus and minus, star and division, divided by operators having highest priority so that you can push. But now top of the stack is star. Now I want to push that operator having least priority. less priority. Got it? Then directly you cannot push. See, if the operator having highest priority than top of the stack, no. So we can't push. Then what we have to do? Else pop the highest priority operator first. Pop the highest priority operator first. Pop the highest priority operator. Then it is empty, na? Empty. Then repeat the fourth step. If it is an operator, yes, if it is stack is empty, then you can push. Then you can push. You got the point. Only this is the point you need to understand. If the top of the stack is right least priority, now you are adding highest priority is okay. Now the operator has least priority than top of the stack. Then first you need to pop highest priority one. Then you need to push the least priority one. Remember that point. Even equal priority also. Equal priority also remember. So based on that, you just try all these things. So many examples I have given. You keep on trying. And not only this, the program I'll explain tomorrow, not today. But today you need to convert this prefix also. Same like, but small modifications are there. Small modifications I already highlighted. First, reverse this expression string. Reverse. Okay, now there actually, if plus is there, you can place a star. Only highest priority. If star is there, even you cannot place star again. Same priority not allowed. Divided by not allowed. First you have to pop that star multiplication, then you need to add this one. If it is only highest priority, you have to push. Even equal priority is also you cannot push. But in prefix, same priority also you can push. If already star is there, if it is star, you can push like this. All these are same priorities. Na? Same priorities you can push. Suppose if plus is there, minus same priority, you can push it. Plus, you can push like this. So that's why only that point I highlighted. Look at this. First, reverse the expression string. Do all the operations. And final output again we should reverse to get the prefix. With example, I'll explain. You will get the clarity. Here, first, we should make it reverse. X plus y multiplied with z, that's simply z multiplied y plus x, reverse it. So first, if it is an empty, stack initially empty, is an operator, operand, you can output it. If it is an operator, same story. If the top of the stack is nothing, empty, then you can push. Next to y, directly output it. See, look at this. If it is plus, first you need to pop highest priority one, then push least priority one. Least priority one. Then X, output it. If no more input, directly unstack the operator and output it. So finally, this is the expression came, but this is not the prefix expression. Reverse that. This is what prefix expression. Reverse expression. See, in this one, we are just coming in reverse direction. Na? So that's why just a small differences are there. Small differences. In reverse order, first closing parenthesis will come, not opening parenthesis. If it is a closing parenthesis, push it onto the stack. B directly output. plus operator, if top of the stack is closing parenthesis, you can push. A is directly, you can output it. If it is opening parenthesis, reverse. Until closing parenthesis encountered, unstack all the operators and add to the prefix expression. So empty. Now if it is a operator, stack is empty, push it. Y is an operand, so add it. Next, look at this. It's a least priority, na? So first unstack, then it is empty, then you can push this plus X, output it. Finally unstack that plus and add. Just reverse. And finally, this expression you have to reverse into prefix. Reverse into prefix. That is. Okay. Like this. Today you have to complete only just take all these expressions and convert into postfix and prefix. Tomorrow, programs, only these two important. Few more are there. Prefix to infix, postfix to infix, postfix to prefix, prefix to postfix. These four expressions we are doing with the help of binary search tree model. Like a tree model, this one also we'll see. Once it is completed, first conversion algorithms. After conversion, evaluation algorithms are there. These are evaluation algorithms. We'll see that evaluation algorithms are easy. Same is almost. Okay. Then we can go with the graph. Next 2 days it will take expression evaluation. Today you just complete, do the conversions and programs tomorrow. Okay, now you can leave.